right, in real life, when you're looking at harmonic motion, which are relationships that can be modeled by sines and cosines, the amplitude a lot of times does not stay the same. So for example, with a spring. When you pull a spring out, it's not going to go back and forth for eternity. The amplitude or the amount that it goes back and forth will decrease as time goes on. So let's look at this problem. So you've got a natural length of 10 centimeters. It's pulled out 4 centimeters. So by that, I mean we bring it out 14 centimeters. And then it's released. And you can imagine what happens. It goes back and forth, and then it kind of slowly slows down and goes back to its natural length. So the information, it oscillates 3 times every 2 seconds. Its amplitude decreases by 15% each second. And we want to find the function that models the length of the spring t seconds after being released. So let's look at what we know. The spring will oscillate on either side of the natural length, which is 10 centimeters. What that means is when we're done with our function, we're going to have a plus 10 on the end because it goes back and forth between 10, above 10 and below 10. The oscillation has a period of 2/3 seconds. When it oscillates 3 times every 2 seconds, if you flip that relationships, every 2 seconds it goes around 3 times. That's seconds per revolution. So we know the period is 2/3, and we have this relationship which gives us B equals 3 pi. On top of that, it begins at 14 centimeters, so we know we have a positive cosine model. And the amplitude starts at 4 centimeters and decreases by 15% each second. So that's an exponential model. So pretty much every t seconds, you lose 15%, which means you still have 85%. This is going to be our amplitude. What we end up with for the length at time t is this function. There's our amplitude, there's our positive cosine with the appropriate b, and what we like to call our midline. And if you graph it, it looks something like this. Notice, of course, we start up at 14 and it goes down and decreases. The amplitude decreases as time goes on.